We first attempt to find the limit as x approaches 9 of the square root of x plus 27 minus 6 over x minus 9. By evaluating the expression at x equals 9, we see that it is of a 0 over 0 indeterminate form. The radical in the numerator prevents cancellation, so we multiply by the conjugate square root of x plus 27 plus 6. Using differences of squares, we simplify the numerator so that there are no radicals. This results in a numerator of x minus 9. Limits are preserved under cancellation where functions may not be. This removes x minus 9 in the denominator, which allows us to evaluate at x equals 9. And the limit as x approaches 9 of the square root of x plus 27 minus 6 over x minus 9 is 1/12. Next, we look at the limit as x approaches 3 of 1 over x minus 6 plus 1/3 over x minus 3. Once again, evaluating this expression at x equals 3 gives a 0 over 0 indeterminate form. In order to do algebra, we must simplify the numerator. This gives us x minus 3 over 3x minus 18 in the numerator. We can then cancel x minus 3's, giving us 1 over 3x minus 18, which may be evaluated at x equals 3. The limit as x approaches 3 of 1 over x minus 6 plus 1/3 over x minus 3 is minus 1/9. We next find the limit as x approaches 6 of x squared minus 7x plus 6 over x squared minus 10x plus 24. Evaluation again gives an indeterminate form. Fully factoring gives us a numerator of x minus 1 times x minus 6 and a denominator of x minus 4, x minus 6. Cancellation gives us x minus 1 over x minus 4, which may be evaluated at x equals 6. The limit as x approaches 6 of x squared minus 7x plus 6 over x squared minus 10x plus 24 is 5/2. Next, we look at the limit as x approaches 5 of x squared minus 7x plus 12 over x squared plus 3x plus 2. Note that this expression is perfectly defined at x equals 5. The limit is simply the value of the expression when x is 5, which is 1 over 21. Finally, we look at the limit as x approaches minus 1 of x squared plus 3x plus 2 over the absolute value of x plus 1. Evaluation at x equals minus 1 gives an indeterminate form. Notice we can factor the numerator into x plus 2 times x plus 1. The absolute value of x plus 1 as a polynomial depends on the sign of x plus 1. From the right, x plus 1 is equal to the absolute value of x plus 1. This allows cancellation. The limit as x approaches minus 1 from the right is 1. From the left, the absolute value of x plus 1 is minus x plus 1. This also allows cancellation. The limit as x approaches minus 1 from the left is minus 1. Since the left and right limits do not agree, the limit as x approaches negative 1 is undefined.